So this problem is actually problem number 5.1.2. We have a situation here where a jet plane actually pulls out of dive. So initially the jet plane is moving like this, okay? It's just diving, and then finally starts pulling out of dive. So it forms kind of a circle. And the radius of the circle is given as 5.2 times 10 to the 3 meter. And so the jet plane is actually moving in velocity. Let's say this, not velocity, in the speed of 525 meter per second. Okay. So when it pulls out of dive, it moves in a circle. The velocity is always changing, but the speed is not. And the reason is because the direction is always changing. All right. The magnitude of the velocity is always the same, which is 525 meter per second, but the direction is changing. And because of the change in direction, you will always have an acceleration that is pointing towards the center of the circle here. And that acceleration is actually called the centripetal acceleration. And that's what we're trying to find out here. All right, let's go ahead and find out the centripetal acceleration. So actually, the centripetal acceleration is given by AC, which is v squared over r. And if you plug in this value here, you have speed 525 meter per second, and the radius of the circle formed here is 5.2 times 10 to the 3 meter. So if you just plug in this value here, you're going to get 53 meter per second square. Okay. Now we have to represent this number in terms of g. Now let me remind you, let me take you to the second page here. So remember, 1g is going to be equal to 9.8 meter per second squared. So the centripetal acceleration, which was 53 meter per second squared, is going to be 53 meter per second squared times 1g over 9.8 meter per second squared. So the final result would be 5.41 g.